Hi, I'm Faisal Khan, Cisco Collaboration Instructor at Voice Bootcamp. In this video, you're going to learn about security requirement. Now, security requirement is one of the most important topic pretty much any domain of your IT. Now here in collaboration, we're going to talk about some of the same security topic that you probably are already familiar with. In this topic, we're going to discuss some of the security requirements around collaboration. Now, to be fair, a lot of these security requirements that we're going to talk about pretty much can apply to any type of network that you are going to design or work on. So collaboration is no exceptions. However, there are a few things that we would like to discuss about which are exclusively to so let's go through a couple of those things that we need to keep in mind when we're designing network or troubleshooting a network. Is that the environment that you are currently working on. You need to have a proper understanding about your network topology. Make sure that you understand how the infrastructure is designed to either deploy new solutions or troubleshoot a solution. So from a security standpoint of view, of course, one of the most first important thing you have is called the firewall. Now, every organization that you go, whether small or big or large scale, they all pretty much have firewall. Even your home network have firewall. So companies would use firewall to block certain type of traffic coming in or going out depending on company's policy. So it is important that you will have to understand how far the concept of firewall and how it works so that you can easily either troubleshoot or make recommendation whenever you do need to deploy or troubleshoot an environment. The same principle that apply if you are going to deploy a Cisco routers with access list. So for example, you could have routers and switches in your network where it could have certain type of access list to allow certain type of traffic coming in or allow certain type of traffic to go out. So it is important that you have that understanding as well. Now they may apply in a different routers, switches, but you need to know which path your traffic is going through, or you need to work with someone who understands that to be able to help you figure out your issues. Now the main premise around all of this discussion is, of course, making sure that you are familiar with the flow of the traffic, that you should know that from your client how the traffic is going through, which path it takes to reach your call manager or CUCM, which ports are open, which devices are connecting, how many routers are in between that. So all of these are covered as we go through these sections and this course. So we're going to be discussing different type of protocol and how firewall behaves around that protocol. We're going to just be discussing things like RTP, what protocols such as SIP use, what port number H.323 use or whatnot. So now understanding this from a security standpoint is really the understanding the port that are required to allow access through these devices so that you can either open them up in your devices or recommend someone else to open it based on their experience. So for example, when you're dealing with something like a SIP, and you need to be aware of the fact that by default it uses the port number 5060, then you need to ask yourself the questions. Does my firewall or my access list has port 5060 open for either TCP or UDP depending on what you're using? You're also going to be looking at port 5061 if you're going to enable secure connections. So these two ports would be utilized for exchange of your core signaling throughout your network from the phone all the way to your call manager. Now, of course, if you got firewall or access list or any other type of security device that possibly block these ports, then you need to work with the network team or yourself, log into those devices and pretty much either allow them or uncheck the settings that might enable you to route the traffic through. Now, from RTP perspective, there is one little bit trick. Because it does not use a particular port, it uses a huge range of port. So you need to enable a large number of port on in firewall to allow RTP traffic to pass through. Because see, in RTP you cannot control what port it actually uses. it just picks a random port from a range of numbers, which makes a difficult convincing case for the firewall team to allow that type of traffic to pass through. So it is important that we identify how to control or look after those type of appliances. Now, for example, firewall, you have the ability to do things like identify RTP packet, and then of course, based on the identity, you realize this is a real time, and you should be able to determine what ports are negotiated during the whole setup phases, and either to allow them or deny this traffic based on your corporate policy. So the real key thing to take away from here is to understanding that from a security standpoint, we have to understand the flow of the traffic, which path the call is going through. Is it going to go through the firewall? Is it going to go through a couple of routers before it reaches the firewall? And does those routers have some sort of access list to block the traffic? Because if you do, you need to be able to open those entries as well. Now, once we have, let's take a look at very briefly here that if this telephone down here, for example, wish to communicate with a CUCM on the devices that are sitting at the very top in the topology, for example, then you have to understand how this traffic is passing through. Is it going through straight through this path, or is it going to take through this path, then it reaches them? Because you need to have a proper understanding how the traffic will be established. Signaling will then take places from the call manager cluster and through these devices to be able to reach that phone. And you will only pick one direction in a multi-high availability structured network. So even though you have a multiple path to reach your call manager CUCM from point A to point B, it is possible that you always take a different route in a different scenario based on how your routing infrastructure is designed. But the signaling will always be this north-south flow of traffic. Now, once this has been negotiated, RTP, which is the real-time protocol, will be then between the two phones. So for example, imagine that you got phone A is trying to call phone B. Well, in that case, the traffic has to go all the way to call manager and then coming through the B from a signaling perspective. But when it comes to, for example, RTP, then you could be directly talking to each other as if they're next to each other. So that is because the nature of RTP is always point to point. Now, of course, there is no direct communications. There is no signaling directly between the two phones. So in this case, you have to understand that if there is a firewall between the phone, even for example, when the phone needs to communicate phone A to phone B, then you may go through a switch which may have an access list blocking your RTP port. Once again, it is important to identify whether the type of flow of traffic would be allowed or not. And if this multi-layer switch that has access to access control list that blocking traffic, you do need to pay attention to those rules and allow them on this, bypass them. You have to something that decide part of your networking. It is also important to understand authentication. So it is possible that you may have an authentication server somewhere in your network that before the phone communicate with call manager, they may need to authenticate and authorize before they are able to access the network. So in this case, a call manager can have authentication on his local database, but it can also use to contact LDAP server somewhere sitting in your environment to authenticate the server. Again, between the LDAP server and the call manager, if there is a firewall, there is a port open, then you need to make sure that those are enabled or passed through your firewall. So from, again, a security point of view, these are all part of configurations that you need to pay attention to. But how about physical security, port security? Let's say that you want to be very, your environment is very tightly controlled, so that the phone can only use if they are connected from certain, Ethernet port, for example. So which is we call port security, where you can hard code the MAC address of the device that is connected to the port, so that if you connect another device onto that port, that device will not be connected to the network. So having all this understanding, it will definitely help you have a better knowledge about designing your network, administering and deploying your network, and of course, at the end of the day, troubleshooting network. So really, to focus on the next couple of slides, we'll be going through the highlight as far as the different type, how we start dealing with such things, such as SSHing to the server or using HTTP. We need to have all those understanding as well. So securing a various component in your Cisco collaboration solutions is necessary to protect the identity and confidentiality of your voice and video calls. As in this scenario, an IP phone data across a network, the data is only as safe and secure as the device that are transporting the data. Depending on the security level that is defined in your security policy, security of the network device might have to improve or might be sufficiently secure for the transportation of your IP telephony network. So if your physical security of your device is weak and can be easily compromised, then so can your voice data. So there are the best practice available for your data network. So ensure that you apply that to your environment. Make sure that everything is followed properly, such as certain protocols or services should be disabled, and so that it cannot be used to kind of fool the system or bypass some certain type of connectivity. You should also use Firewall wherever is possible, and access list authentication services whenever you are able to identify an individual. So more services you extend beyond the internal network, with internal network potential subject to an internal attack. So in that case, you may want to decide whether you want to have some sort of encryption or authentication mechanism between the phone and the server. So you could use a certificate to authenticate, you could use OAuth to authenticate, you could use SAML authentication, single sign-on authentication, many different security devices that you can implement to ensure that your network is protected. If unauthorized users can capture traffic, then the user cannot decrypt the content of the package if it is already encrypted. But if it is not, then you can easily capture the packet and analyze the password details and maybe even the conversation, who knows. So always to make sure that if you are a high sensitive environment such as the bank, the government, then you may want to think about encrypting your IP packet. Encryption also provides authentication, because through the use of digital certificate, each device will authenticate the other device to ensure that they are who they say they are. Authentication can be one-way or two-way process. Now, for example, in one-way authentication, the client of an administrator or an end user authenticate web server, but the server does not authenticate the client. Authentication can also be two-way, where using a mutual transport layer protocol, or MTLS, where the server will also authenticate the client to ensure that the both side actually has had a chance to authenticate each other. MTLS, which is used for example signaling between the endpoint and Cisco Unified Communication Manager, to which they are registered to. So not just the IP phone will authenticate the call manager, but the call manager will also authenticate the IP phone. In this case, we're going to use a transport layer protocol, TLS, in a method for encrypting the TCP traffic, and is commonly used for web services traffic and SIP signaling. TLS client, which basically connects to a TLS server, initiates a TLS connection. Client establishes a TCP connection with the server by sending a hello packet. For example, right here, I'm going to say hello to the server. Now, these sending a client hello packet that contains a random number and a client's capability. These capability include list of cipher suite that client can support, the technology that it can support. The TLS server, in this case authenticate other side, will then select one of these cipher suites from the client capability, and typically taking that into account, the cipher suite preference of the client replies with the server hello packet, and this message also includes another random number and the server certificate so that the client can authenticate. Now in this case, a figure illustrates that your client will be initiating a hello packet. Server will send a hello packet with a server certificate to ensure that the client can trust the connectivity. So two steps for establishing TLS sessions. Sorry about that. For simplicity, it does not include all the message and possible variation of TLS handshaking. The server certificate could be sent in the server hello message, or could be sent separately if you want to, for even better security. Now, CTL and ITL are one of the topic that we're also going to go deep into it. Certificate trust list, which is an identity trust list, are the files that include in Cisco Unified Communication Manager. The endpoint, the IP phone, will then download this file when they boot and restart. In that case, you need to restart when they download this file. These files allow endpoint to get the minimum set of configuration call manager certificate that it needs to trust the call manager services. CTL and ITL files are signed by the system administrator security token and contain list of records. Each record contains a certificate of chain role, functions, and pre-extracted certificate field for easy lookup by the endpoint. So this is the overview of some of the security discussions that we're going to have throughout this course and throughout subsequent course, which you will need to be familiar with and have a good understanding of it. I hope you got some information, valid information from this video, and I will see you in the next video.